Everyone watches NVIDIA. Everyone watches TSMC. Everyone watches ASML. But before any of those companies ever touch a chip, two software companies have to approve the design. They sit in California, not Taiwan, not the Netherlands. They have 73% of the world's chip design market between them. Every NVIDIA H100, every Google TPU, every Apple M chip, every custom ASIC inside Amazon, every chiplet on every hyperscaler accelerator pass through their tools first. The AI race depends on hundreds of billions in fab capacity, on EUV machines that cost almost $500 million each. But none of that matters until a designer at NVIDIA or Broadcom clicks compile in software made by these two companies. That is the real choke point, and almost nobody outside the industry has heard of them. Their names are Synopsys and Cadence. Synopsys was founded in 1986 in California by Art Degusse, an engineer who ran the company for nearly 4 decades. Cadence was formed in 1988 by merging two early design automation startups. For 35 years, these two have circled each other inside a market that almost no outsider tracks. The category is called electronic design automation, or EDA. It is the layer of software that turns a chip designer's intent into a physical layout that a foundry can actually manufacture. Without EDA tools, no modern chip exists. Not a phone processor, not a CPU, not a GPU, not an AI accelerator. The third player, Siemens EDA, has about 17% share. Synopsys and Cadence split the rest almost evenly. Together, they make roughly $12 billion in revenue per year, with operating margins above 30% that the largest semiconductor companies would envy. They are not commodity software vendors. They are the gatekeepers between design and manufacture. Over the next 10 minutes, we will look at 4 things: what Synopsys actually sells beyond the tools, and why their IP business is the real engine; how Cadence built a different kind of moat through verification and emulation; the part nobody outside the industry sees; the foundry partnerships that make their tools structurally impossible to replace; and why AI and the cloud are not going to disrupt them, they are going to entrench them. Start with Synopsys. The company sells 3 things. The first is design tools, the actual software that converts logic into silicon: Fusion Compiler, Primetime, VCS. These tools have been refined for 35 years, and they are how nearly every advanced chip gets compiled. The second product is DesignWare IP, pre-built circuit blocks for things that every chip needs, but nobody wants to design from scratch: USB controllers, PCI Express interfaces, DDR memory physical layers, Ethernet, ARC processor cores. A single advanced chip might integrate 40 or 50 Synopsys IP blocks. Synopsys charges an upfront license plus a per-chip royalty, measured in cents, sometimes in dollars. Multiply that by billions of chips, and the IP business has grown from roughly 22% of revenue 5 years ago to about 35% today. Tools are sticky, IP is recurring. The third leg is the Ansys acquisition that closed in 2025, a $35 billion all-stock deal that gives Synopsys multiphysics simulation, heat, electromagnetic interference, structural analysis. AI chips run at thermal densities the industry has never seen, and the only way to design them now is to simulate the whole stack: the die, the package, the board, the rack. After Ansys, Synopsys is the only company that can do all of that under one license. They became the end-to-end design vendor for the AI era. And once a customer has used their tools to build 5 generations of chips, the cost of switching is essentially infinite. Cadence took a different path. Their dominance starts with Virtuoso, the standard tool for analog and mixed signal design. Every chip that talks to the physical world, power management, radio frequency, sensor interfaces, runs through Virtuoso. There is essentially no alternative for advanced node analog. On the digital side, Cadence sells Innovus and Genus, but the part of Cadence that competitors cannot touch is verification. Modern chip verification consumes roughly 70% of all design effort. Cadence sells 2 layers for it. The software layer is Xcelium simulation and Jasper Gold formal verification. The hardware layer is Palladium, racks of custom emulation hardware that physically prototype a chip in advance of tape-out. A single Palladium rack costs between $5 and $15 million. NVIDIA owns dozens of them. AMD owns dozens. Every major hyperscaler ASIC team rents time on them. You cannot ship a modern GPU or AI accelerator without weeks of Palladium runtime. And Palladium is built on custom Cadence silicon that nobody else makes. That is a hardware-locked moat sitting on top of software. Under CEO Anirudh Devgan, Cadence has spent the last 5 years extending downstream of the chip. Sigrity for signal integrity, Allegro for printed circuit boards, Celsius for thermal analysis, Clarity for three-dimensional electromagnetic simulation. The argument is that AI chips no longer end at the die. They include the package, the substrate, the cooling, the power delivery, and all of it has to be co-designed. Cadence is the only vendor selling every layer of that stack from a single license. Operating margin above 35%, recurring revenue near 90%. Now, the part of the EDA industry that almost nobody outside the supply chain sees. Every advanced manufacturing node, TSMC 3 nanometer, Samsung 2 nanometer, Intel 18A, comes with a process design kit, or PDK. The PDK is a multi-gigabyte bundle of physical models, design rules, parasitic extraction libraries, and characterized transistor data. Without it, no software can produce a layout that will actually work in the fab. Foundries do not hand out the PDK to anyone. They share it only with EDA partners who have completed a multi-year qualification process. Synopsys and Cadence have been doing that qualification for every node since the late 1980s. The reference flow they build with TSMC for a new node takes hundreds of engineer years and millions of dollars of correlated test silicon. The corner libraries, characterizing how a transistor behaves at the slowest process corner, highest voltage, hottest temperature. Those measurements come from physical wafers run through the fab and pulled apart in a lab. Decades of that data sit inside their tools and nowhere else. Open source EDA projects like OpenRoad can match the algorithms at older nodes. They cannot get a TSMC 3 nanometer PDK. The foundry will not certify them, and foundries themselves prefer this arrangement. 2 qualified vendors is enough to keep prices reasonable. Adding a third would multiply support burden across thousands of customers. So the duopoly is reinforced from above by the foundries and from below by the customers. Every advanced chip designer is trained on Synopsys or Cadence tools in university and joins a team that already uses one of them. The switching cost is not just buying new software. It is recharacterizing the entire IP library, retraining the engineering team, and convincing the foundry to qualify a new flow. Nobody does it. The most common misconception about EDA is that AI will disrupt it. The actual semiconductor industry view is the opposite. AI is going to entrench the duopoly further than it has ever been. 3 reasons. First, both companies launched their own AI-driven tool suites 4 years ago. Synopsys ships DSO.ai. Cadence ships Cerebrus. These tools use generative algorithms to explore design space, placing logic, routing signals, optimizing timing at speeds humans cannot match. Claimed improvements range from 3 to 15 times faster runtime and 5 to 20% better power and performance results. The flywheel is that these models are trained on years of customer design data. Nobody else has that data. OpenRoad does not. A hyperscaler in-house team does not. The training set is the moat. Second, the cloud has not disintermediated them. It has expanded them. Amazon, Microsoft Azure, and Google Cloud all sell EDA as a service. The underlying licenses still come from Synopsys and Cadence. Cloud actually grew the addressable market by letting smaller fabless startups access tools that previously required dedicated server farms. The 2 giants get more customers, not fewer. Third, customer concentration in AI works in their favor. The design cost for a leading-edge AI accelerator at 3 nanometers is now between $500 million and $1 billion per chip. Roughly 30 to 40% of that goes to EDA tools and IP licensing. As designs concentrate into fewer, bigger customers, NVIDIA, AMD, Broadcom, Marvel, and the hyperscaler ASIC teams, those customers spend more, not less. Each new generation of complexity translates directly into Synopsys and Cadence revenue. Here is the verdict. 2 layers, not the 4 or 3 of previous episodes. Synopsys first. They built the only end-to-end vendor in the industry. Design tools plus the largest IP library in semiconductors, plus multi-physics simulation after the Ansys merger. Recurring revenue above 90%. Ratable through multi-year subscriptions that the largest fabless companies cannot exit without rebuilding their entire design flow. Their AI tools, DSO.ai and VSO.ai, get better every quarter because the training data flywheel runs only inside Synopsys. They are the dominant vendor by revenue and arguably by depth. Cadence second, a different shape of moat, narrower in IP but wider in system. Virtuoso owns analog design. Palladium is hardware that nobody else can replicate. Their package, board, and thermal tools extend the design flow beyond the die into the rack. Their operating margin is roughly 36%, higher than Synopsys and higher than NVIDIA's gross margin outside data center. Smaller, more focused, more profitable per dollar of revenue. Together, they sit at a structural choke point that no foundry, no hyperscaler, and no national chip strategy has a short-term path around. 3 risks worth tracking. 1. China's domestic EDA ecosystem, led by Empyrean Software and Primarius, is improving but still 1 to 2 nodes behind. Sufficient for mature node manufacturing inside China, not for advanced AI silicon. 2. Foundry bundled tools. TSMC could in theory acquire or build its own EDA layer. They have shown no interest, preferring to keep EDA neutral. 3. Hyperscaler in-house design teams. Google has tried this internally for years. They still license Synopsys IP, and they still rent Cadence Palladium. The pattern across every disruption attempt is identical. The duopoly absorbs new technology and then builds the disruptor for it. That is what a structural monopoly looks like. 2 companies, decades of customer lock-in, and an AI cycle that pays them more, not less. This was episode 1 of a new series, Forgotten Monopolies, the companies that almost nobody outside the supply chain talks about, but that decide what the industry can actually build. Next episode goes 1 layer down, into the physical substrate itself. 2 Japanese companies, Shin-Etsu Chemical and Sumco, produce more than 55% of the world's 12-inch silicon wafers between them. Every single chip ever made by TSMC, Samsung, Intel, or anyone else starts on a wafer from one of them. The duopoly is older, deeper, and even harder to disrupt than EDA. If this episode taught you something nobody else is talking about, subscribe for the actual semiconductor industry view of the AI race. See you in the next one.